In the last video, I stated that units could be used not only to just make unit conversions, but also as a tool for problem solving. So in this video, I thought we would do a few problems and practice using the units to guide how we do the problem. Right? One of the equations that was mentioned in your reading was the relationship between distance, speed, and time. So one thing that's neat about units is that they prevent you from having to memorize equations. Right, so the equation happens naturally just as a result of the relationship between these various units. So if you forget this, all you need to do is think about some common units. All right, so speed, everybody knows miles per hour for driving for cars. All right, so we can use maybe a sample speed. Right, we can just think of that in terms of miles per hour. Right, and distance. Okay, well then let's think of distance in terms of miles, right, since we've already mentioned miles and hours, and we can think of time in terms of hours. Right? So let's say that you forget there's some sort of equation that relates S, D, and T, speed, distance, time, or maybe you know rate, distance, and time. But if you don't remember what that is, you can figure this out just based on the units. All right, so notice you could get speed, which is miles per hour. Right? Well, how would you get miles per hour using these other two things, miles and hours? Right? Well, per means divide. Right? So you can get miles per hour by taking miles and dividing it by hours. All right? Or in other words, you can get speed by taking the distance in miles and dividing it by the time in hours. Right? So there's one example of an equation. You could use S equals D divided by T. Okay, how would we get distance? By using speed and time. Right, well, if you take miles, right, how are we going to get that? So let's take the speed and time and see what we can do with those to try to get miles. Right, so if I take the speed, miles per hour, right, and let's say you don't know initially, so let's say you try to divide that by time. Okay, divide it by hours. Right? So there's that rule, invert and multiply. Right? So this is miles per hour, and then instead of dividing by hours, you would multiply by the reciprocal of that, which would be 1 over hours. And then this is going to give you miles per hour squared. All right? So what we've done is combined speed and time, and we did it in such a way that we did not end up with distance. We didn't end up with miles. Right, so that gives you a clue that this is not the right way to combine them. Right, so let's back up and do something different. Okay, what if we multiply instead? Well now, all right, you have hours in the numerator and hours in the denominator, and those cancel, and that leaves you with miles. So what this tells us is that if you take the speed and you multiply by the time, then you get the distance. Okay, so there's another equation that you could use. Speed times time is distance. Okay, and finally, let's try to get time by combining speed and distance. All right, so our goal is to get hours. All right, so if you take miles per hour and you multiply by miles, okay, because you might remember it's some sort of multiplication or division, then you're going to end up with miles squared per hour, which is not the units we want. It's not hours. Okay, so let's back up and let's try division. And then we'll use that invert and multiply rule. So miles per hour, okay, divided by miles is the same as multiplying by 1 over miles. Okay, and then the miles in the numerator and the denominator cancel. And this leaves us with 1 over hours. Okay, so that's a little bit weird. It's still not quite correct, but notice it's closer. We at least got rid of miles, right? But this is flipped. We wanted hours, and instead we have 1 over hours. Right, so if that's the case, let's back up and kind of flip-flop these two things, and let's see what happens. Okay, and I'm switching those just to see, but my clue is that I ended up with the correct units, but sort of flip-flopped. One's in the denominator when it should be in the numerator. So what happens if we take miles and let's divide that by miles per hour. All right, so this is miles times, right, and multiply and invert. So this is going to be hours per mile. And now the miles in the numerator and denominator cancel, and we're left with hours. And that's what we wanted. All right, so that tells us that taking the distance in miles and dividing by the speed in miles per hour gives the time. All right, so there's a third equation you could use. So now you have some options. You can kind of generate any one of these equations and then apply that to specific problems, or you could kind of repeat this process specifically every time you do a problem with, with specific miles or specific hours. And if you just follow the units, then you'll know just by looking at those whether or not you're generating the type of answer you want to generate. Right? So if you're looking for time and you don't get hours, then there's a problem. This next problem is a real one for me. So this is a picture of some shortbread cookies, and this is my favorite shortbread recipe. I don't even remember how I found this, but I made these cookies for a bridal shower, and the shortbread was amazing. So I put the web link here to this blog. This is where I got the picture from and the recipe. And this is originally written in French, so I used the Google Translate to get this into English. But here's the recipe, and you'll notice that everything's in terms of weight, and it's all metric, right? So if you have a digital scale, then it's not too bad to try to measure these things. Like you can measure flour just by weighing it rather than in cups. But for butter, you do have one other option, right? So if you wanted to know, and here's where the problem came in. I did have a digital scale, but I needed to know how much how much of these ingredients I should buy, right? So for butter, it's not really easy to kind of weigh that out if you haven't bought it yet. But I did know that butter comes in sticks, and I know that sticks weigh a certain amount. So what I thought I would do is just convert the grams of butter needed into sticks, and then that would tell me how much to buy. All right, so there's the backstory. And for this recipe, I needed 180 grams of butter. Now, of course, for the shower, I think I made 3 or 4 batches, but I've made it since then and just made 1 batch. Right, and I also looked on the butter, and typically a stick of butter is 113 grams, which is kind of annoying. It doesn't really divide evenly with 180, but that's what we had to work with. Okay, so let's try to make this conversion. I want to know how many sticks of butter. All right, and I'll put a question mark there. All right, so that's what I'm trying to get. I want to do some sort of a unit conversion that ends up with sticks. And let's say you didn't know how to do this. All right, so just by following the units, this helps you understand the problem. So you want to start with what's known, which is the weight in grams. And then if we follow the units, we're trying to end up with an amount in sticks. All right, so along the way, I would, if you didn't know to look for a conversion factor, maybe this would be a clue that you're, trying to convert from grams to sticks, and then you can look that information up. And then mathematically, what do you do to solve this problem? Well, let's start with what's known, 180 grams, and I want to know how many sticks that equals. All right, so you can just start right in, all right, and we can multiply. All right, so I can multiply by any fraction that equals 1, and this was mentioned in your reading as well, but this is why we're allowed to do this. Right, so all we're saying with the equal sign here is that we have 2 things that are the same thing. Right, so 180 grams is of course the same as 180 grams. Now when I multiply, there's a risk that I'm changing that amount, but I wouldn't be changing it if I multiplied by 1. I'd still have 180 grams. Right? I also wouldn't be changing the amount if I multiplied by 3/3 because that's just 1. Right? So if I multiply by some conversion factor, all those factors are things that are the same, so they're also equal to 1. Right, so in this case, I can multiply by 1 stick per 113 grams, and the reason I can do that is because it's the same thing. A stick is the same thing as 113 grams. Okay, so let's say you actually messed this up, and let's say you did 113 grams per one stick. Right, so if you look at the units first, I think you'll see the problem here. Right, so when you multiply the units, you're going to get grams times grams divided by stick. So this is going to give you grams squared per stick, and that doesn't answer the question. We're trying to figure out how many sticks, not how many grams squared per stick. Right, so that's the clue that you need to switch the conversion factor and just flip that. Per 113 grams. Okay, and then so now the units cancel correctly, grams and grams cancel, and then we can go back and deal with the numbers, and we're doing 180 divided by 113, and that's about 1.59 sticks. Okay, so I knew it was about a stick and a half of butter, so that at least answered my question of how much butter to buy, but as for actually making the recipe, I went one step further. I knew that there were 8 tablespoons per stick, so I wanted to know I knew it was a whole stick, and then I needed to know how many tablespoons out of the next stick, because then I could just cut off that amount in the butter. All right, so I did one more thing, and I took 1.59 sticks, and I got rid of the 1. Okay, because now I'm just finding what portion of the second stick to use. All right, so 0.59 sticks, and then you can multiply that by 8 tablespoons per stick. All right, and the stick cancels, and we should get an answer that's in tablespoons. And this turned out to be about 4.75 tablespoons. Okay, and so that was a nice enough number to work with, and I stopped there. Another common type of conversion problem is currency. Right, so this is the current exchange rate as of the time that I made this video for euros and US dollars. Right, and I found this online. 1 euro is about equal to 1.14 US dollars. Right, so I was in Ireland a number of years ago, and one of the things we did every day was, of course, eat. And being on vacation, we ate out, so it was helpful to kind of have an idea in mind of how much food would cost and sort of what was reasonable and what wasn't. Right, so if I was going out for a nice meal, like maybe I was doing shepherd's pie or something like that, and expecting to pay restaurant prices, maybe I would think maybe around $16 would be a price that I would expect as kind of mid-range in the United States. So if you wanted, you could convert this to euros and just see kind of maybe what menu prices you would expect to pay. All right, so we have this this equation, which is stating that these two things are equal. Right, so we can make two conversion factors here. Right, you could do 1 euro divided by $1.14, right, or you could flip it and do $1.14 per euro. Okay, and of course, if you look online, you'll find other ones that have a different number here. So you can do like 1 US dollar to multiple euros. So any of these will work. You just need to be careful of the units and how you're multiplying or dividing these things. All right. So what I know, I have this price in mind, 16 US dollars, and I want to see about how many euros that would be. Okay, so I want to convert from dollars to euros. So I'm going to multiply. Okay, so 16 is this dollars is the same as $16 times any fraction that equals 1. Right, and I want to just do this in such a way so that the units cancel. Right, so I have dollars in the numerator that I'm trying to cancel. So I'll put dollars in the denominator, and I'll put euros in the numerator. Okay, and then you can fill in whatever numbers you have. So in this case, it would be 1 euro and $1.14. All All right, so dealing with the units first, dollars cancel, and that does give me euros. So it looks like this is set up correctly. And then you can go back and do the numbers, which would be 16 divided by 1.14, and that's going to give about 14.04 euros. All right, so what that tells me is that whatever price I see on the menu, I can just expect to pay a few more dollars than that number. Okay, so it's a really rough estimate, but if I see like 22 euros as the quoted price, then I know it's a little bit more expensive than that in dollars. Okay, let's end with one more problem, and I've chosen something that has made up words here just to make a point, which is that you can use the units as a problem-solving tool even if you're not really sure what the problem is talking about or how to approach this, or if you don't have a good perspective on comparisons between different things. All right, so if you're familiar with the poem Jabberwocky, this is from the book Through the Looking Glass by Lewis Carroll. Okay, or I think it's a sequel to Alice in Wonderland, but it's the same author of Alice in Wonderland. All right, so if you're familiar with that poem, then these words will look familiar to you. If not, maybe you want to pause and look this up just so you don't think this is crazy. All right, so here are some made-up numbers. The numbers are not in the original poem. All right, so we have there are 20 tum-tum trees in the Tulgey Wood. In each Tulgey Wood is one frumious bandersnatch. There are 5 slithy toves in 2 borogoves. There are 2 mome raths per Jabberwock, 2 jubjub birds in 200 tum-tum trees, 200 mome raths in each borogove, and 5 jubjub birds per slithy tove. So let's say that for some weird reason you need to know if there are 5 frumious bandersnatches, how many Jabberwocks are there. All right, so again, let's use that same process to try to understand this. And again, understanding does not mean knowing what these words actually mean, but we have some information to begin with, 5 frumious bandersnatches, and then we have some information that we need to figure out, okay, how many Jabberwocks. And then we'll just let the units guide us. All right, so let's find Jabberwocks in this information, and I see it here. Okay, 2 mome raths per Jabberwock. So what that tells me is that I can write Jabberwocks in terms of mome raths. Okay, so not helpful quite yet because what I know is bandersnatches, not mome raths. All right, so let's look for mome raths elsewhere in this information, and I see that there are 200 mome raths in each borogove. So I can write mome raths in terms of borogove. Okay, and then looking for borogoves elsewhere, we have 5 slithy toves in 2 borogoves, so I can go from borogoves to slithy toves. All right, and I see down at the bottom there are 5 jubjub birds per slithy tove, so I can write toves in terms of birds. And then there are 2 jubjub birds in 200 tum-tum trees, so I can write the birds in terms of the trees. And there are 20 tum-tum trees per wood, and in each wood there's a bandersnatch. So finally I've made this little trail backwards, and I know that I can get from Jabberwocks to bandersnatches, so I should be able to get from bandersnatches to Jabberwocks. All right, so looking at the units ahead of time tells me how this will work, and we can just do a little chain of unit conversions to get from one to the other. All right, so let's set this up, and we'll start with bandersnatches and try to end up at Jabberwocks. Okay, so I have 5 bandersnatches, right, and I can multiply by anything that equals 1. So that second line tells me in each Tulgey Wood is 1 frumious bandersnatch. Okay, so I have 1 bandersnatch per 1 Tulgey Wood. Okay, so notice here we're not saying that the wood is equal to a bandersnatch, but it is sort of equal to 1 in that it's 1 per 1. Okay, so if you have one, you have the other. All right, and just so I don't get too confused, it's already confusing enough. I've used that entire line, so I'm just going to cross that out, and I know I don't have to look at that anymore. Okay, so what I have now, if you look at the units, Bandersnatches cancel, and I'm left with 1 told you would. So let's keep going, and I want something that will convert told you would into something else. Okay, so we see 1 told you would is 20 tum-tum trees. All right, and notice I'm still trying to cancel, so if would is in the numerator, that's why I'm putting it in the denominator. Okay, so I've used that fact. How about tum-tum trees into something else? All right, there are 2 jub-jub birds in 200 tum-tum trees. Okay, so 200 trees is 2 birds. And then there are 5 jub-jub birds per slithy tove. So 5 birds per tove. All right, there are 5 slithy toves in 2 borogoves. In 2 borogoves. And going on to the next line, still multiplying. Okay, there are 200 mome raths in each borogove. All right. And finally, there are 2 mome raths per Jabberwock. Okay, so 2 mome raths per 1 Jabberwock. Okay, so quite a long setup, but let's go back through and just confirm that all the units work out. So Bandersnatches cancel, wood cancels, the trees cancel, birds, toves, borogoves, and raths. And this leaves me with Jabberwocks as the unit, which answers the question. So now all we have to do is go back and do the multiplications and divisions. All right, so I like to do this let's do all the multiplication and all the division. All right, so this is in the numerator, we've got 5 times 20 times 2 times 2 times 200. And in the denominator, I have a lot of 1s, but I do see 200 times 5 times 5 times 2. Okay, and then you can multiply everything out and divide it. Or another thing you can do is cancel the numbers just like we did the units. Right, so I see 200s that cancel, some 2s cancel, and some 5s cancel. So now I'm left with, in the numerator, 20 times 2, and in the denominator, 5. Okay, so that's 40 divided by 5, which is 8. Okay, so after all of that, there are 8 Jabberwocks. So there you have it. That's a really long unit conversion problem, and just as that last process with the explaining, we sort of did this again as we went along, but to understand the problem, I looked through at the units first, then I solved this, and then to explain, I'm just looking back and confirming, making sure I didn't make any errors, and making sure that we did answer the question, which was the number of Jabberwocks. Right, so everything looks good.